Hello everyone, hope all are doing well. Welcome to Mathnospedia. यहाँ पे मैं स्टार्ट करने जा रहा हूँ लेक्चर 8 ऑफ आवर कोर्स बेसिक टू एडवांस लेवल रियल एनालिसिस. Our topic of discussion is series of real numbers introduction. Our aim in this course is to solve PYQs after discussing each concept in details. So हमारा फुल कोर्स है. पार्ट 1 पे कवर होगा फंक्शन, रियल नंबर सिस्टम, सीक्वेंस सीरीज, कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी. पार्ट 2 पे कवर होगा रीमान इंटीग्रल एंड टोपोलॉजी ऑफ रियल नंबर्स. पार्ट 3 पे कवर होगा काउंटेबल एंड अनकाउंटेबल सेट. पार्ट 4 पे कवर होगा सीक्वेंस सीरीज ऑफ फंक्शन एंड बाउंडेड वेरिएशन. पार्ट 1 एंड पार्ट 2 फॉर जैम एंड नेट, एंड पार्ट 3 and part 4 are only for net. You will get the lectures on Tuesday, Thursday and Saturday at 7 PM. अभी हम लोग पार्ट 1 पे है एंड हम लोग ऑलरेडी फंक्शन, रियल नंबर सिस्टम एंड सीक्वेंस कवर कर चुके हैं. आज हम लोग स्टार्ट करने जा रहे हैं सीरीज. इन द लास्ट लेक्चर हम लोगों ने डिस्कस किया था PYQs फ्रॉम नेट एंड जैम. हम लोग टोटल 13 क्वेश्चन डिस्कस किया था एंड ईच कॉन्सेप्ट्स. हम लोग प्ले लिस्ट पे जाके ये सारी वीडियो देख सकते हो. सो टुडे लेक्चर 8 पे जो टॉपिक यहाँ पे कवर होगा वो है सीरीज क्या होता है एंड इस कन्वर्जेंस क्या होता है. व्हाट इज द नेसेसरी कंडीशन फॉर कन्वर्जेंस ऑफ ए रियल नंबर सीरीज. जीपी सीरीज क्या होता है एंड इट्स एग्जाम्पल क्या होता है. उसके बाद हम लोग देखेंगे पी सीरीज क्या है एंड इट्स एग्जाम्पल. एंड आखिर में हम कॉची कंडेंसेशन टेस्ट देखेंगे. सो जो बुक आप लोग फॉलो कर सकते हो, एनालिसिस बाय स्केमापा, मैथमेटिकल एनालिसिस बाय मालिक अरोड़ा एंड रियल एनालिसिस बाय बाटले एंड सॉबर्ट. सो द बेसिक कोर्स में आप लोग अगर जो टॉपिक्स इस लेक्चर में डिस्कस होगा वो अगर आप डाउनलोड करना चाहते हो तो PDF के फॉर्म में आप हमारा वेबसाइट www.mathnospedia.in से डाउनलोड कर सकते हो. हमारा व्हाट्सएप ग्रुप पे आप ज्वाइन कर सकते हो फॉर नोट्स, इस कोड को स्कैन करके. अगर आप लोगों को कोई भी डाउट हो तो मेल कर सकते हो mail@mathnospedia.in. हम ट्राई करेंगे आप लोगों का डाउट सॉल्व करने को. सो लेट्स स्टार्ट टुडेस लेक्चर. सो दोस्तों, व्हाट इज ए सीरीज. सीरीज क्या है. फॉर दैट लेट अस कंसीडर ए सीक्वेंस an. देन कंसीडर द फाइनाइट सम ऑफ द फर्स्ट n टर्म ऑफ दैट सीक्वेंस a1 plus a2 plus ... plus an. Then take limit as n tends to infinity to Sn. Then this term will goes like this plus ... into infinity. Then that limit n tends to infinity Sn is that, and we can write this as sum n is equal to 1 to infinity an. This sum 1 is equal to 1 to infinity, the infinite sum of that sequence an is called the series of real numbers. हम लोग इसी सीरीज के बारे में अब देखेंगे कब वो कन्वर्जेंस होगा, कब वो डाइवर्जेंट होगा. Now, what does mean by the name convergence? Let us consider the series an. Then it converges to S, a number S, if the finite sum sequence Sn, which is formed by the first n terms a1, a2 ... n, converges to S. If that Sn converges to S, then we will call that the series also converges to S. So to check a series convergent or not, we have to check the finite sum or nth partial sum Sn converges or not. So if lim n tends to infinity Sn is equal to S not is equal to infinity, then we say sum n is equal to 1 to infinity n is convergent and converges to S. Now necessary condition क्या होगा? The necessary condition for convergence of series is that if some series an is convergent, then the limit n tends to infinity an must be 0. So for any sequence, for example 1 by n square, if it is convergent, then 1 by n square must goes to 0, the nth term of the sequence an. This an must goes to 0. This is the convergence of necessary condition for convergence. The converse is not true, because let us take an is equal to 1 by n. Then observe that this hold, limit n tends to infinity 1 by n is equal to 0, but here 1 by n is not convergent, it diverges. Okay, it is divergent. Why it is divergent? We have already seen in the sequence lecture that if you consider the sum Sn is equal to 1 plus 1 by 2, 1 by 3, dot 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 1 by n. This is nothing but the nth partial sum of that series. Okay, we already seen that the Sn goes to infinity. That's why Sn, as Sn goes to infinity, that series also goes to infinity. That's why this series is divergent. So the limit n tends to infinity an is equal to 0, but an series is not convergent. That's why the converse of necessary condition is not true. So necessary condition कब काम आता है? अगर कोई भी सीक्वेंस कन्वर्जेंट होगा तो लिमिट n tends to infinity 0 होगा. So if for some sequence lim n tends to infinity an 0 नहीं होता है, तो so by contrapositive statement we can say that the series an is not convergent. So अगर आपको कोई भी एक सीक्वेंस an गिवन है, आप लोगों का फर्स्ट काम होगा इस लिमिट को चेक करना. अगर ये 0 होता है, then we will go to convergence test. Okay, and if it not is equal to 0, then we directly can say this series is not convergent. Okay, now what is GP series? The GP series of that particular type is called GP series. A first term is A, then if you multiply each term by R, then AR plus AR square dot 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 is known as GP series. So here first term is A and common ratio is R. Okay, this type of series known as GP series. Now the question is when it converges. Remember that if mod R less than 1, then the given GP series is convergent and converges to A by 1 minus R. Okay, and if mod R greater equal to 1, then the series diverges. Now using GP series we can find the sum of that series. First observe that this series is like from n is equal to 1 से start हो रहा है, not from 0. Okay, and GP series कहाँ से start था? n is equal to 0 से. Okay, but यहाँ पे n is equal to 1 से start हो रहा है. That's why the first term is 2 by 3, then 2 by 3 square, then dot 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 जा रहा है. So यहाँ पे a is equal to 2 by 3 and r is equal to also 2 by 3. Observe that r is less than 1. So the GP series is convergent, because we have already seen for r less than 1 it is convergent. So here the series is convergent and converges to A by 1 minus R. So the sum is a by 1 minus r, which can be found as 2 by 3 by 1 minus 2 by 3, which is 2 by 3 by 1 by 3, which is nothing but 2. So the given series is convergent and converges to 2. Let us see another example. Think about this series, whether it is convergent or not. Okay. Observe that we can write the given series as n is equal to 1 to infinity 1 by 3 to the power n third square by 1 by 5 to the power n third square plus 2 by 1 by 3. This is very basic by using formula of a plus b the whole square. Then if you simplify, then you will get n is equal to 1 to infinity here 1 by 9 to the power n plus sum is equal to 1 to infinity 1 is equal to 25 to the power n plus 2 into sum of n is equal to 1 to infinity 1 by 15 to the power n. Now observe that for each case here r is equal to 1 by 9, here r is equal to 1 by 25, and here r is equal to 1 by 15. So in each case r is less than 1. So each series is convergent and the sum is given by 1 by 9 into 1 by 9 plus 1 by 25 by 1 minus 1 by 25 plus 2 by 1 by 15 1 minus 1 by 15. So if you simplify this, you will get the desired sum. So please calculate this. Okay. Now what is p series? P series क्या होता है? It is very important. The series of like this 1 by n to the power p is known as p series. For different values of p, you will get different p series. For example, if you take p is equal to 2, then you will get 1 by n square. If you take p is equal to half, then you will get summation 1 by root over n. Now, when does this p series converges? Remember that the p series converges for p greater than 1 and diverges for p lesser or equal to 1. Okay, so that means 1 by n square will be convergent. Okay, because here p is equal to 2. For p is equal to 1, summation 1 by n, we have already seen this series is divergent. So again by p series, this series also divergent again. And if you take p is equal to half, then 1 by root over n is also divergent. So the by p series, we can easily say whether a series is convergent or not. Now the test of convergence. हम लोग क्या बोले थे, कोई भी एक सीरीज अगर आपको गिवन है n, then your first you have to check whether limit an is equal to 0 or not. If it is not is equal to 0, then you go to divergent. It is divergent. Okay. Now if it is 0, then as the converse is not true, so we can't say an series is convergent. So then we have to go for the test. Now there are two types of test: absolute convergent test and non-absolute convergent test. Now what that mean by absolute convergent test? Absolute convergent test का meaning क्या है? In the case of absolute convergent test, the sequence terms must be greater or equal to 0. That means that has to be non-negative. All the terms of the series will be greater or equal to 0. In that case, that name is absolute test convergence. But in the case of non-absolute convergence test, here n can be greater than 0 as well as less than 0. Both can be possible. For example, for absolute convergence test, the series is like 1 by n square, because here all the 1 by n square greater than 0. Okay. But in case of non-absolute convergence test, remember you can take minus 1 to the power n by log n, this type of, because here for n is equal to what, you will get negative terms. So in that case you have to apply the non-absolute convergence test. Now there are few very important tests we have to learn. First, let us check what are the absolute convergence test. So these are the absolute convergence test, which are the Cauchy condensation test, ratio test, and root test. Okay. And there are few non-absolute convergence tests. They are Dirichlet test and the Abel test. Okay. We will learn each of these tests, how to find them. Now in this lecture we will only discuss Cauchy condensation test, and in the next lecture we will define the rest of the test. Okay. Now what is Cauchy condensation test? Cauchy condensation test क्या होगा? So Cauchy condensation test is a absolute convergence test, and here if an, the sequence is decreasing sequence with an greater than 0 obviously, then it says that both an and 2 to the power n, a 2 to the power n is either both convergent or both divergent. Okay, what that means? That means if you have a series an where the sequence an is decreasing, then this series and this series first replace n by 2 to the power n. n को 2 to the power n से replace करके आपको एक sequence मिल जाएगा, and multiply before 2 to the power n. Then this series and this series are both together convergent or divergent. This is Cauchy's condensation test. Hope you understand. Let us see an example using Cauchy condensation test. Using Cauchy condensation test, we can prove this series is convergent for p greater than 0. The series 1 by n log n to the power p. So let us see. Here observe that our an is 1 by n log n to the power p. So observe that here, as log n greater than 0, n greater than 0, so as a whole n greater than 0, so we can apply the absolute convergence test. Okay. Now 1 by n log n to the power p obviously monotonically decreasing, as we know 1 by n monotonically decreasing, so here log n is multiplied in the denominator, so this is actually monotonically decreasing. Okay, so we can apply Cauchy condensation test. Now let us see what is 2 to the power n, a to the power n. So here replace n by 2 to the power n. You will get 1 by 2 to the power n log 2 to the power n to the power p. Now if you simplify this, you will get 1 by 2 to the power n log 2 n आगे आ जाएगा log property to the power p. Okay, and here n to the power p भी होगा क्योंकि पावर पे p था. Now if you multiply by 2 to the power n both side, you will get 2 to the power n, a 2 to the power n as let us remove this. So what is 2 to the power n? A 2 to the power n, this is nothing but 2 to the power n, and put this value 1 by 2 to the power n to the power p log 2 to the power p. Now this series, cut this, you will get 1 by log 2 to the power p 1 by n to the power t. Now observe that this is the p series because this is constant and this is p series, and p series is convergent for p is equal to 1. So that's why the original given series is also converges for p greater than 1. That's why the given series is converges by p series is greater than 1. Okay. So that's it for now today. We have to stop now. In the next lecture, we will discuss series test for convergence. The rest of the convergence test we will discuss in the next class. So till then, goodbye.